Okay, now it's question number 10. The graph of the curve y equal to this passes through the 2 points 0, 2 and 0.514. Find the value of p and q. So what we are going to do, we are going to replace the value of x and y over here. Okay, first point is 0, 2. So x is 0, y equal to 2. So 2 equal to p. 4 to the power 2 times 0, that's going to be 0. Let me write down 4 to the power 0 minus q 4 to the power 0. 2 times 0 is 0, 0 is 0. Now over here I can write down 2 equal to anything to the power 0 equal to 1. So p minus q. Okay, so that's, I have one of the equation, but we're gonna replace this value. So make this one p. If I bring this one over here, 2 plus q. All right, then another point is 0.514. So y is 14 and p, now 2 times 0.5, that's gonna give me 1. So 4 to the power 1 minus q, and this 4 can be written as 2 square, and x is going to be 0.5. 0.5, that's actually makes 1. So 14 equal to 4p minus, that's actually 1. So it's 2q. I can take 2 common. So if I can take 2 common over here, so it's going to be 7. Cancel out that 2p minus q. And I have p over here. So I'm going to replace this p with this value over here. So therefore 7 equal to 2. 2 plus q minus q. Okay, replacing. You can write down this. Replacing the value of p by 2 plus q. Okay, now what happened if I take this one off, this bracket off, 2 2s are 4 plus 2q minus q. So that's gonna give me q. Okay, only q. And when I bring this one over here, 4, this is addition, so it's gonna be subtracted. 7 minus 4 equal to 3. So we got the value of q to be 3. Now when we put this value over here, p equal to 2 plus 3 equal to 5. So we can write down answer p equal to 5, q equal to 3. Okay, that's that. The variable, second part of the question B, the variables x and y are connected by the equation y equal to 10 to the power 2x minus 2 times 10 to the power x. Using the substitution u equal to 10 to the power x, or otherwise find the exact value of x when y equal to 24. So let me write down this equation. Y equal to 10 to the power 2x minus 2 10 to the power x. Now we can write down this 10 to the power x square. Okay, because I can replace 10 to the power x by u. And this is 2 10 to the power x. Now we replace that u square minus 2u. Okay, we got this one. Now look at this. Find the exact value of x when y equal to 24. So we're gonna replace the value of y by 24 here. Okay, so 24. If I bring this 24 to this side, it's going to be u square minus 2u minus 24 equal to 0. Just do the middle term break. So what can we do? 24. So we can write down probably 6 times 4. That's difference is 2, and product is 24. So u square. But I need to have this. Look at this. 1 times 24 equal to 24. But this 24 is negative. Okay, so negative. Product is negative. I have to have product negative. So either one of them has to be negative. Now it's negative 2u. So if I put negative over here, negative 6 times 4, still negative 24. But when I add that, it's going to be negative 2. So this is the pair I'm looking at. So u square minus 6u plus 4u minus 24 equal to 0. Taking u common, u equal u, then multiply u minus 6. Taking 4 common here, u minus 6 equal to 0. Just draw a line to make sure that I come from here to here. So that's going to be u minus 6, and here is going to be u plus 4 equal to 0. Therefore u equal to 6 or u equal to minus 4. Now remember, u was 10 to the power x, so this is 6, and this is 10 to the power x equal to minus 4. This value is rejected because this is the base. Base cannot be negative whenever we are using the logarithm, so we just cancel that one out, reject it. Okay, so that's, we are not going to worry about that. Now this one, take log base 10, common logarithm on both sides, log 10 to the power x equal to log 6. Now x comes over here. Now log 10 nothing but 1, log 10 base 10 equal to 1. This is log 6, x equal to log 6. You can keep it as it is because it says exact value of x. Don't try to find out this value. We have this habit that whenever we use calculator, we can use the calculator, we can use calculator like this, and we say x equal to 0.778. Okay, 3 significant figures, and you are pretty happy with that. But remember, it says exact value x, so don't touch it. It's the exact value. This is the approximate value, so this is, don't take this one. Okay, take this value. Okay, now next one, solve this one. You can see that log with the base same base, so we don't need to change the base. What are you going to do? We have minus. We know that when we have minus, we can keep the same base. It's actually divide those two. Okay, that equal to 3. So we can write down, this is the number, x plus 1 divided by x equal to 2 to the power 3. That's going to give you 8. So x plus 1 equal to 8. Bring this one to that side. So it's multiply 8x. Bring this one over here. So 7x equal to 1. Or you can write down x equal to 1 by 7. So that's done for this question number 10. Coming to question number 11. The function f is defined for all real values of x. Function of x equal to x minus x squared. We're going to do completing the square. Okay. So to do that, what are you going to do? We're going to take the negative sign common first. X squared plus x. Now this one, whenever we do the completing the square, I just do this one. A square plus 2ab plus b square. Now x comes over here. Now this x goes there, but I have to have only one x. I already have 2x over here. I need to cancel this 2. So what can I do? I can just multiply that half. So 2 to cancel out. I'm gonna leaving with only x. Now this thing goes there, 1 by 2. Now this equals to that, and this whole thing equals to that. This one I wrote extra, so I'm gonna subtract this one. Okay, I'm subtract this one. So this equal that, this equal to this, and this to cancel out. So I haven't changed anything. Okay, now if I take this one outside of the bracket, so minus minus plus, so it's gonna be minus, and this whole thing I can write down x plus half square, and when I take this one outside of the bracket, negative negative becomes positive. It's going to be 1 by 4. Now it says the greatest value of function of x. Now this is a non-negative value over here. Okay, it's a square, so it never gonna be negative. So the lowest value can get is 0 when x equal to minus half. So function of x, since this is negative, the greatest value would be 1 by 4. Function of x, the greatest value would be 1 by 4 when x equal to minus 1 by 2. That's the answer over here. Okay. Now it says the domain of g of x equal to x minus x squared is such that this one has an inverse. Okay. Inverse exists. Explain why y is greater than or equal to 1 is a suitable domain. First, instead of, if I don't want to do this one completing the square, if I take minus x common, so it's going to be x minus 1. Okay, the reason I'm doing this, I can get two roots of this, x equal to 0, that one, and x equal to 1. Just put it over here, 1. Okay, remember when x, actually, you know what, I made a mistake here. It's going to be minus. Okay, when I take this minus sign, it's going to be over here minus, and this is going to be minus, and then this thing happens when we have this plus over here. So this 0 and 1, and this is going to be half. And when it's half, let's put this one 1. So 1/4 is over here. The graph is going to be like this. Okay. This value of a over here is -1. A equal to -1. When a is less than 0, the curve looks like this with a maximum value. Okay. So that one. Now if you look closely, when x equal to half, this particular point, half and 1/4. When x equal to half, y equal to 1/4. That's the maximum. Okay. Now over here, if x is greater than or equal to 1, so we are talking about this part over here. This, from this value, x is greater than half or less than half will do. Only if we just restricted our domain to this part, either x is greater than or equal to half, or x is less than or equal to half. This function g of x will have an g inverse. Okay, it will have an inverse. So therefore, if I take this x is greater than or equal to 1, this graph is decreasing for sure. Since it's gonna have maximum point over here, it's decreasing for greater than 1. If we take less than 1, then it's increasing. So even though we know that this is suitable, but this is more suitable, we know that it's decreasing, and the maximum point is that it will never reach there. It will keep going on below of x-axis and keep going on and on. So what you can say, since g of x is decreasing when x is greater than or equal to 1. Okay, therefore domain x is greater than or equal to 1 is a suitable domain to have g inverse. Okay, all right. Now next one, the function h and k are defined for this, where x is greater than -2, and k of x is this when x has a range of values. The domain is greater than 1 but less than 101. It says find hk10. So this is composite function. So hk10. So k10, whenever we put k10 over here, so we got 5 plus 10 minus 1. That's gonna be 9. So we're gonna have h, this is 5, and this is a perfect square, so it's going to be plus 3. So we're gonna have h equal to 8. Okay, 5 plus 3 is 8. Now h of x says log, now this is log 8 plus 2, that's log 10, and we know that log 10 base 10 equal to 1. So this hk, let's put it this way, hk 10 equal to 1. So that's our final answer. Okay, now find k inverse of x. Okay, stating the domain and range of this k inverse. Okay, so we have kx equal to 5 plus square root x minus 1. If we take this one as y, so 5 plus x minus 1, bring this one over here. So x minus 1, and this is y minus 5. To get rid of square root, put a square on both sides. This cancel out. So x minus 1 equal to y minus 5 whole square. So x equal to y minus 5 whole square plus 1. So k inverse would be x minus 5 whole square plus 1. That's our k inverse. Okay. Now what we need to do, we need to find out its domain and range. Okay. Now you can see that there is no domain given. We have to find, even though no domain is given, we have to find out domain and range. But since no information given, we look for this k over here, k of x. Okay. Now k of x, its domain was 1, x is greater than 1 but less than 101, and range, when we have that, what was its range? If we take this 1 over here, put this 1, so it's gonna be 5. Look at this, 1 minus 1 is 0, square root 0 is 0, so 5, so it's going to be 5. And when we put 101 over here, minus 1, that's going to be 10. 5 plus 10, that's going to be 15. So its k of x was 5 to 5 plus 10, 15. Now we know that inverse functions, domain is the range of functions. Like this one, it's going to be 5 k of x. This is inverse, okay, and it's going to be 15. That's the domain of this one. And then range would be, its range would this is x over here, and its range would be k inverse x is 101. So answer, you can write down for k inverse x, domain would be 5 to 15, greater than 5 but less than 15, and range would be greater than 1 but less than 101. Okay, so that's this one. Now we're gonna come to the last math, number 12. It's trigonometry, finding the angles A in between 0 to 180 degree. Now this is sine square A and cos. What are you gonna do? We're gonna use the trigonometric identities. We can write down sine square A instead of sine square A. We can write down 1 minus cos square A. So we're gonna have the same trigonometric ratio over here. Plus 2 cos A equal to 7. When you take this bracket off, 8 minus 8 cos square A plus 2 cos A equal to 7. If we take everything to that side, it's going to be 8 cos square A minus 2 cos A. This is plus, this is going to be minus, so minus 1 equal to 0. Okay, minus, yeah, that's minus 1. Okay, now it's 8 times minus 1, the product has to be minus 8, and then difference has to be 2. So if I take 4 times 2, that's gonna be 8. I need at least one negative values to make this product negative, and since this is negative, we're gonna take the negative factor, the bigger factor to be negative. Now when we add that, it's going to be minus 2. So these are the factors, pair of factors I'm looking at. So 8 cos square A minus 4 cos A plus 2 cos A minus 1 equal to 0. We are taking 4 cos A common, so having here 2 cos A plus 1 common, 2 cos A minus 1 equal to 0. 4 2 cos A, and that's going to be minus 1 over here. Taking 2 cos A minus 1, 4 cos A plus 1 equal to 0. Therefore, for this thing, 2 cos A minus 1 equal to 0 or 4 cos A plus 1 equal to 0. So cos A equal to half, A equal to cos inverse half. Okay, and it's in degree given, so I change my calculator mode to degree, and then it's gonna be cos inverse 0.5. I got 60 degree. Now when it's 60 degree, cos is positive in the first quadrant and fourth quadrant. Now fourth quadrant is out range, so I'm not gonna go there. So this is the only one value, and over here cos A equal to minus 1 by 4. Therefore A equal to cos inverse minus 1 by 4. Cos inverse is minus 0.5. That's gonna be 104.5. Okay, now that's in the, when it's negative is gonna be in the third quadrant and second quadrant and third quadrant. So third quadrant is out range, so answer would be this two, 60 degree and 104.5 degree, this two. Okay, now we are coming to the next one. cosec 3b plus 1, treat that one as theta. Okay, don't change that now. Okay, 1 by cosec can be written as sine 3b plus 1 equal to 2.5 radian. Now when it's like that, we can write down this one, transpose that. It's going to go up here, it's going to come down here. So it's going to be sine 3b plus 1 equal to 1 by 2.5. Then 3b plus 1 equal to sine inverse this. Okay, I'm going to change my calculator mode to radian again. Now it's going to be sine inverse 1 by 2.5. So I got 0.4115. I'm taking some extra values over here. Now this is 3. Remember, we have to divide by 3. So what are you going to do? It's positive, and positive happens here and here for sine theta. Okay, so this is going to be theta, and this is going to be pi minus theta, since it's in the pi radians. Okay, in the radian mode. So it's going to be pi minus 0.4115. So that's 2.7301. Okay, we have to figure it out that this 3 will divide these values. So we can go some more values so that we're gonna get all the values. We don't want to miss any values from this range given. Okay, range of values of b given. Okay, so since I have theta, if I add this to 2 pi, then I'm gonna go another revolution and come back to this one. So with this, I'm gonna adding 2 pi. So 0.4115 plus 2 pi, that's give me 2.5855. And then if I this value doesn't look right. Let me see. 2 pi plus 0.4115. Yeah, it doesn't look good. 6.6947. And then with this one, 2.7301 plus 2 pi, I'm gonna have 9.013. Should I go more? If I go more, then I'm gonna now add 2 pi with this one. 6.6947 plus 2 pi. That's gonna be the third revolution, but it's 12.97, almost 13. Divided by 3, it's gonna go more. Okay, so we don't need any more. Okay, but let me put this one, 12.9778. I want to show you something. Now what happens? B, we need B. Look at this. I have to subtract 1 from each of this value and then divide it by 3. Okay, I hope you can see that. If this one was 3b plus 1 equal to, if this one was, let's say, x, then b would be x minus 1 divided by 3. I hope you can see that. Okay, so b is going to be 0.4115 minus 1. That's that, divided by 3. So I got minus 0.196 in this particular value. And this one is going to be 2.7301 minus 1 divided by 3. It's going to be 0.5767, so 7, 3 significant figures, and 6.6947 minus 1 divided by 3. I got 1.898, so it can be written as 1.90. Okay, and then this value 9.013 minus 1 divided by 3, that's 2.671. And look at this one, 12.9778 minus 1 divided by 3, I got 3.9926. You know that the value of pi is to be 3.14159, so it's out range. This is negative, so 0 to that. What we are looking for is these 3 values. So answer B gonna be 0.577 radiant, 1.903 significant figure radiant, and then 2.67 radiant. Okay, that's the answer. Okay, so we finished that. Thank you very much.